Okay, so we're going to be factoring a difference of squares. Um, so this is one of our two special cases that we're going to look into. So please write this down. Um, when factoring quadratic polynomials, a difference of squares can be factored as follows. And now we've already looked at this pattern before when we were talking about multiplying difference of squares. We're just going to do everything in reverse. So it's going to look like this. A squared, take away b squared, factors into the sum and the difference of a and b. So a plus b times a minus b. Um, so we got difference of squares follows this pattern. And so let's just take a quick look at why this works. Here's an example, kind of the why. So let's say we're asked to factor the following. X squared, take away 16. And we're going to say, okay, let's say we don't know this pattern yet. And I want to factor it the method we've been factoring before. So I want x squared, that's fine. That's my quadratic term. And I got my constant term, minus 16. What I don't have is the linear term, the term with x. Remember how we fixed that? I would say plus 0x, then minus 16. Okay. So this converts into that. We can do a quick x problem with negative 16 and 0. Yeah, we're going to get negative 4, positive 4. And since we don't have a leading coefficient other than 1 here, we can go right into factoring this into x plus or minus 4, whichever one you want to put first. Voila. Okay. But I want you to notice one thing, and we have to think in terms of square roots. If I take the square root of x squared, what's my answer? X. So there you go. If I take the square root of 16, 4. Yeah, 4 times 4 is 16. So basically, think of in terms of square roots. So the more efficient way would have been start with this, x squared minus 16, and then you say, okay, this is a difference of squares. This is a perfect square. X squared is a perfect square. So we recognize this is a perfect square. and this is a perfect square. So this works because both terms are perfect squares. And then we could say, all right, the square root of x squared is x. Goes here. That's our a value. It's like the a value there. The square root of 16 is 4. And that would go here. It's always plus and a minus. And you recognize the following. Get a different color. The square root of x squared. Remember, raising something to the 1/2 power is square rooting it. Also, what's 2 times 1/2? 1. And x to the 1 is just x. Okay? And the same thing with this. 16 is just 4 squared. So that's a perfect square. And you raise that to the 1/2 power. And 2 times 1/2 is 1. 4 to the 1 is just 4. That's how we end up with x and 4. But just recognize those are perfect squares. So if we can see that, you can use the pattern right away. And factoring difference of squares is also easy. Okay. So let's say we have x squared minus 9. Just recognize, do we have 2 perfect squares? Yes. Yeah, we do. X squared is a perfect square, obviously, and 9 is a perfect square. So if you have that, just put a plus and a minus. Figure out what your a value is. So I'm going to we could probably figure it out in our heads, but I'm going to write it down. A, instead of a, I want the square root of x squared, which is x. Instead of b, I want the square root of 9, which is 3. So our answer would be x plus 3, x minus 3. Okay. All right. Any questions? All right. Let's try number 2. Let's say we have 4x squared minus 81. Again, let's figure out what our a value is. This time we want the whole term there. Well, also x squared. A could be more than one thing. That's the part you got to keep in mind. So the whole a squared part, this whole thing is a squared. Just like this is b squared. So my whole a squared value is 4x squared. We want the square root of 4x squared, 2x. So this time our a value is 2x. And what's our b value going to be? 9. Square root of 81 is 9. Okay. So we do have difference of squares there. Because 4 is a perfect square, x squared is a perfect square, and 81 is a perfect square. So put a plus and a minus. We have 2x plus 9 2x minus 9. And if ever we need to check, just multiply them back together to make sure you get this answer again. Okay. Let's try this one, number 3. This one's going to look a little different, but it is still a difference of squares. (36m to the 4th minus 1). Okay. So what number squared gives me 36?
6m.
Well, just start with this. What number squared gives me 36? 6. What number squared gives me m to the 4th? M squared. If you take m squared and you square it, you get m to the 4th. Okay? So over here, our a value is 6m squared. 6m squared. Okay? Because if I square this, I would get 36m to the 4th. Any questions? Okay. Let's figure out what b is. If I square root 1, I get 1. And 1 times 1 is 1. So that's kind of the unique one, right? But it's its own square root. So tell me, what's going to be our answer here? 6m squared plus 1.
6m squared minus 1.
6m squared minus 1. You multiply these together again, you would get 36m minus 1. Any questions? That one's a little tough, but if you caught it, you see it, even those are pretty easy. All right. Here's a challenge one. Number 4. 6n squared take away 54. What do you notice? Anything? Do we have a perfect square here?
No.
No, 6 isn't a perfect square, right? Yes. Yeah. If it looks like you don't have perfect squares, because 54 isn't a perfect square either, right? Some number times itself doesn't give me exactly 54 other than the square root of 54, which you don't want to mess with. But if that happens, what you want to try next is, can I factor something out? Is there something that I can divide out? And 6 does go into 6 and 54. So let's factor out a 6. Okay. Let's take out a 6. If I divide out 6, 6 times what gives me 6n squared? So n squared comes out. Then you have a minus. 6 times what is 54? 9. And lo and behold, that is a difference of squares. N squared is a perfect square and 9 is a perfect square. So now let's factor that. So now we're going to use difference of squares here. What's my a value here? N. What's my a value for 9? 3. Or my b value, I should say. So now I know the whole answer. What's my first factor? 6. And we have n plus 3 and n minus 3. We just factored that completely. So I want you to try that on your own for this next one. Number 5. 3x squared take away 12. 3x squared minus 12. Okay, obviously 3 is not a perfect square, 12 is not a perfect square. Check and see what you can factor out. That's what I did there. All right. Okay. Let's do a couple of them. Let's do number 6. Pablo factored using difference of squares. Explain his mistake. So take a look at what I'm going to write after this. A little error analysis. So you had 100x squared minus 81x, and he came up with 10x plus 9, 10x minus 9. Go ahead and write that down. You had 100x squared minus 81x, and you said my answer is 10x squared, 10x plus 9, and 10x minus 9. But there's a mistake there. Take a look. Jesse, are you holding up your pencil, or you want to give us 81x? What's wrong with 81x?
Since it had that x and we subtract all of the x's that we multiply the next plus 1 and the next minus 9, we only get negative 81.
Right. Yeah, this is the issue right there. The x right there. If you multiply this back, you'll see that you won't get that answer, right? You'll get 100x squared minus 81. If I multiply these two together, I get 100x squared minus 81, not 81x. So that x disappears in this. Yeah, the problem is, well, let's take a look at this. 100x squared. Is that a perfect square? Yeah, both of them are. 100 is a perfect square. X squared is a perfect square. 81, is that a perfect square? 81 by itself is a perfect square. How about x? Is that a perfect square? No, it's not. Both sides, both terms rather, have to have perfect squares. So the problem is here. In the second term, 81x is not a perfect square. So let's say this. In the second term, 81x is not a perfect square. And we'll do the last one now. Okay. So in the last question, we're going to say a rectangular pool at Pacoima Park has an area of 196x squared minus 49 square inches. What are the dimensions of the pool? All right, let's take a quick look. Go ahead and write that down. Rectangular pool at Pacoima Park has an area of 196x squared minus 49 square inches. What are the dimensions of the pool? Okay, that's our question. So when they're asking us for dimensions, what is that? Jesse? Length and width. So we got our pool. And here's the water. And it's 196x squared, take away 49. So that's the area. 196x squared minus 49. But we want the length and the width. How can we find that? What do you think? What do we have to do to find the length and the width? Or what do we have to do to find the area? Yeah. So they're asking us to factor this, right? So what would the length and width be? Yeah. So let's factor this. 196x squared minus 49. What are the two factors we get? What is it? Well, how about 196? It is a perfect square. 14. 14 times 14 is 196. So it's 14x plus 7. And then 14x minus 7. Okay. Who's a good candidate for, let's say it's this shape, where the length is longer than the width. Who's our candidate to be the length? Yeah. 14x plus a little more, 7 more square inches, I guess. So 14x, let me fix that. 14x plus 7 inches, and then 14x take away 7 inches. There you are. Those are our dimensions. All right. Any questions?